Hi, I am Putri and this is my EM3 assignment. So we're going to be discussing the Euler's method formula. So this is the formula. So what we're calculating is actually the next estimated value. So what we need is the current y value, the h, which is the step size, which is how much you move forward on the x-axis, and also the derivative point, which is your dy dx. Now dy dx that we're working with is given here, and we're also given when x equals to 0, y equals to 1, which can be our initial state, and our step size is 0.1. So we're moving on the x-axis by 0.1. So we increase by 0.1, which is over here. And when do we stop? When x equals to 1, because that is our question. So we stop at when x equals to 1. Now this end value is just to help checking how many steps there are. Equals to 0 is just to show that its initial state, which is x equals 0, y equals to 1. And this is just the calculations to ensure that when I compare it with my Excel sheet, it is the same. It is quite similar. Now focusing more on my Excel sheet, this is the main plots. They are directly from this table, but this focuses more on using the formulas here, and they are just using of the different columns but using the same formula. To further explain the Euler's method rule, I've crafted an example. So this is my equation. So I've actually used Desmos to make the curve, and this is the actual curve for this equation. So these are the actual plots, the y plots, and the increment is by 0.2. Now I've calculated using the Euler's method, and these are the y values that I get. And this is the curve that I get as well. Now as you can see, there is a slight difference due to the inaccuracy of the Euler's method rule. Now, to cross-refer to ensure that these y values are correct, I've used my Excel sheet. I've changed the dy dx over here according to the dy dx here. Differentiate this equation, you get 2x, which I've done the changes accordingly. And I've used the values of the column C as I'm using the x values here. And I'm using the Euler's method formula again. Now the reasons for this inaccuracy of curve can be explained through the analysis of the approximation error. Now first we're going to find the exact solution through calculation. So first we're going to integrate y and x, and then we're going to sub in my x equals to 0, y equals to 1, which is the initial state, to get the general solution over here. Now we're going to sub in x equals to 1 because that is what the question is asking for, and we'll get this. Next we'll be calculating using the Euler's approximation. So this is the formula, and we want to find when x equals to 1, which we already calculated from the Excel sheet. Now to find the approximation error, we get the exact value calculated over here minus the Euler's formula, and you get the approximation error. Now the reasons for this error margin is because of Euler's method and its low accuracy. Now unless we use small step size, its accuracy will be low. So 0.1 is quite small, but it can decrease to 0.01, which is the smallest as it gets. So with a small step size equals to a higher accuracy. And that concludes my EM3 assignment.